Hi all of you. Here is the third PPT for us and the first of the algebra. We are again with the maths, the previous year CAT questions, the questions that will take care of the revision. So in this algebra PPT1, I've actually taken set of 5 questions. Of course, I told you they are actual CAT questions, but they're making a family again. And this time my theme is, we are taught in the school that if you have one variable, then one equation is enough for us to get the answer of that. But if there are two variables, then we need two equations. And if there are three variables, we need three, and so on. But CAT has had habit of giving questions which spoils this notion. You have got two variables but only one equation, and there's no can't say as the option, right? So how do we go about this? So that is the family of questions I have here. So let's see the first question. If a plus b root 3 the whole square is 52 plus 30 root 3, where a and b are natural numbers. Thanks. Natural numbers at least bring some certainty in it. Otherwise, we get a feeling that there are infinite such numbers. Then a plus b equal to, there's only one equation. There are two variables a and b, and we have to reach the answer. One obvious method is let's square both sides or first expand that. Um, but I'll tell you what this family nudges us. LHS equal to RHS, get the comparison done and see how well you can bring this in the simplified form where the comparison is pretty evident. That's it. So for a while, leave the left hand side as it is. Let me play with the right hand side. This is a plus b the whole square. Can I bring this in a plus b the whole square form? For a while, 52 is as it is for me. 2ab is 2 into of 15 root 3. Now I still, this is 2, that's the constant. This is a into b, and I have to now reconcile 52 as the sum of two perfect square, a square and b square, and ab is 15 root 3. Obviously there is root 3 in between. So how can I play with this is 15, if I take this as 5 into 3 root 3. I will change this if it is not giving me the form of 52 as the sum of two perfect squares. 5 square is 25. 3 root 3 square is 9 threes are 27. 27 and 25 is 52. That's fine. So now I can write this as this is 5 square and this is 3 root 3 square, that's 27, and in between it is 2ab. So this is a square, this is b square, and I'm done. So I'm writing this as 5 plus what is b for me? B is 3 root 3 square. All is well. And now simply compare this with a plus b root 3 the whole square. A is 5 and b is 3. If a is 5 and b is 3, our answer is 8. And that's your answer. Option number 3. So if you find out the previous year CAT questions, you will find quite a few questions of this type. That's a very prototype method for us. Bring it in the form where LHS can really be compared with the RHS simply, easily and quickly, and you have the answer. Let's see how's the next question. Two equations this time, nice. But look at the unknowns. P, K, Y, X. There are 4 unknowns, and how will 2 equations suffice? So we'll again have to do something. For some constant real number P, K, and A are considered, consider the following system of linear equation where X and Y are there, and a necessary condition for the system to have no solution is, you remember the 3 types of equations where we have unique solution. This is equation 1, this is equation 2, you have a unique solution. Second example, this is equation 1 and this is equation 2. That's infinite solution because they represent the same line. And third, this is equation 1 and this is equation 2. They have no solution because the lines are parallel. They will never have a commonality in them. And this is what is told, condition for the system to have no solution. The case number 3, right? Case number 3. case number 2 and case number 1. Unique solution, infinite solution, and no solutions. So what happens in no solution? If the equation is ax1 plus by1 equal to some constant, and this is ax2 plus, or let me just write this as a1, b1, and this is c1, a2, b2, and this is c2. That will be better. Let the suffix of x be as it is and the suffix of b be as it. So with no solutions, a1 upon a2 has to be same as b1 upon b2, and that's the reason they don't meet. But it should not be equal to c1 upon c2, because if that is equal, then the equation is apparently the same. It just multiplied by some constant to LHS as well as RH. So for this case, p upon 3 should be equal to minus 4 upon k and should not be equal to 2 upon a, right? So what do we get from this? If I play with this, p into k is equal to minus 12, or I can write pk plus 12 is 0. Fourth option says it is not equal to 0, so this is gone. Now let me play with these two. 2 2s are 4, minus 2 into a is equal to k. Goes that side, 2a plus k equal to, in fact this should not be equal to 0. So I have a ready-made form of that, and that's my equation or inequality, right? So option 1 is directly giving this. So it's a perfectly theory-based question. All you need to know is this. Otherwise, it's a child's play. Yeah? Third, when Rajesh's age was same as the present age of Garima, the ratio of their ages was 3:2, past tense. When Garima's age becomes the same as present, now the present, past and future are getting intermingled. The present age of Rajesh, then the ratio of the ages of Rajesh and Garima will become how much? The future part. So we at Bullseye have been playing with such equations. Again, you see there are a lot many variables, the unknowns, and the equations are not matching them. So just make a grid. Let's say this is past, this is present, and this is future. And this is Garima, and who is the other fellow? Rajesh. That's it. If you can fill this up, I think we are done. First line, when Rajesh's age was same as the present age of Garima. Rajesh's age was, that's past tense. Rajesh is here, past is here. So this is same as the present age of Garima. So I'm taking it as x. Then what happens? The ratio of their ages was, dono ka past tense. The ratio of their ages, their as in who is first? Rajesh is first. 3:2. So this is 3x and this is 2x. So I've changed this, so I'll adjust this. So far so good. Garima has graduated by x. So even this guy has grown older by same x. So if 2x plus x is 3x, then 3x has to go ahead by x years. When Garima's age becomes, that's future, same as the present age of Rajesh. This is present age of Rajesh and this is the future of Garima. Again, if Garima has grown older by x, from 3x to 4x, it's x more. So even Rajesh has grown old by x. Can you believe we are done? That's it. The ratio of the ages of Rajesh and Garima. This is Rajesh and this is Garima. 5x divided by 4x is 5:4. That's it. So that's the grid pattern. See, there are three tenses: past, present, future. With the conventional equations, I think we'll have our head blown over. So this is always preferred at Bullseye. Fourth, x and y are real numbers such that, my God, it's a big polynomial. Then the value of 4x plus 5y. Again, the equation is just one. The unknowns are more than one. X and y, two unknowns as such, but they are not separately asking us the value of x and the value of y separately, but 4x plus 5y is asked. One idea is somehow get 4x over there. Say I can break 4x square as 4x into x, and for me to generate 5y, somewhere here I can start doing that. I'll start with the conventional idea. If it doesn't work or if it is too lengthy, then we can get back and do something which is the plan B. But to start with, we can write this as 4x square. I'll take this first. A square minus 2ab plus b square is a minus b the whole square is what is going in my mind. So this has to have a y square here. But that's 4y square. So I'm having 3y square to adjust that. So I did this, I did this, I did this. I need to have this and this. So these three can be written as 2x minus y the whole square. How about this? I can take 3 common first. Y square minus 2y plus 1 is 0, and even this gets settled. 2x minus y the whole square plus 3 times y minus y minus 1 the whole square is 0. Now, we don't have a RHS. In one of the question I said you bring it in the simplified form where LHS, RHS can be compared and there remains only one possible combination. That's not as easy here. But if you see, the right hand side is 0. It has to be 0 plus 0 equal to 0, or this is plus and this is minus. But they both are squares. How can they be minus? So they both should be 0. And for this to be 0, y has to be 1. And for this to be 0, y is 1 now. So 2x minus 1 is 0. 1 upon 2, x is half. Nice. So what do we want? 4x plus 5y. So 4 into half plus 5 into what? 1. So that's 2 plus 5 and our answer is 7. Classic and beautiful question of one equation and more than one variable. And this is how we get onto it. Fifth question. Looks like a quadratic. In fact, it is quadratic. The roots alpha and beta of the equation 3x square minus lambda x minus 1 equal to 0. This satisfies another equation. And look at that. We want alpha cube plus beta cube. The whole square is what? Okay. So some of the roots, I'll start with that. What is, there's only one unknown. So the roots are given to me as alpha and beta. I write the sum of the roots quickly. Coefficient of x square is 3. And the product of the roots is plus c upon a is 3. Okay. Then this part, I can write this as alpha square plus beta square divided by alpha beta the whole square equal to 15. Alpha beta, I have that, it's minus 1 upon 3. I don't have value of alpha square plus beta square. I'll quickly get that. Alpha square plus beta square can be alpha plus beta the whole square, and to compensate the unnecessary 2ab that has come, I subtracted this way. So alpha plus beta is available with me. I'm just putting the values that are readily available and trying to simplify to the extent possible. This is minus, minus, minus becomes plus, and shall I write it as this way? I'll still simplify this further. I can't do anything more than this now. Simplified. Now what? Now I have this. I want to reach this value. Before that, I'll just put this, something that I have found, I'll put it in this. Right? Alpha square plus beta square, I'm substituting. The denominator is alpha beta the whole square. And the product is minus 1 by 3, that's 1 by 9. And this is equals to 15. So still simplifying this is 1. Oh, nice. I think I have two possible values, plus and minus 3. Whoa, it's lengthy question. Finally, I have to now get onto this. I need to simplify that first. So I'm just rewriting this alpha cube plus beta cube. The way I wrote this alpha square plus beta square in the form of alpha plus beta and alpha beta, so that I utilize the information that is there with me. Minus trying to compensate that unnecessarily generated 3a square b 3ab square by multiplying it this way. So what is alpha plus beta? There I have that's cube. What is alpha plus beta? The same value. What's alpha into beta? Minus 1 by 3. Just trying to simplify this. Minus minus plus, and this minus 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 plus, and this minus is finally minus. How about 3? 1 3 goes off, and I'm left with this. Let me just check this. Minus is all right. This minus is all right. Minus minus plus, I think I'm okay with this. So if I take this as plus 3, then 3 cube is 27 divided by 27 plus 3 is being taken. So this is minus 1 and minus 1. I get this as minus 2. What if this is minus 3? Minus 27 and minus, that's plus 27. Minus 3 and minus, that's plus 3. And that gives me 2. What did I do? I found out the value of alpha cube plus beta cube as either minus 2 or plus 2. In both the cases, if this is minus 2, the square is 4. If this is plus 2, the square is still 4. And hence, I have a unique value that is 4, and that's option number 3. It's a big question, but yep, there are 1 or 2 questions in CAT where the length is inevitable. And in the process of shrinking it unnecessarily, the inertia or the flow gets spoiled. So I prefer some question if you can do it in 1.5 to 2 minutes. There are some questions which can take 3 minutes, so that the average time is around 2.5 minutes. So this is a classic question again. Equations are lesser than the variables, and this is how it takes to solve it, right? Yeah, that was the last question. So I'll come up with algebra 2 or maybe the percentage applications in the next session. And again, I'll try and ensure that I have a family for you so that it doesn't act only as a revision of past few questions of the CAD, but you get a lesson to learn and you can practice similar questions. So what if they are not actual CADs? You can also ask the AI to generate similar questions. You can get 20 questions of similar type. And once you get a real good flow over it and the thinking process gets reduced in the actual exam, I think we did it for us. So thanks a lot. I'll come up with the next PPT soon. See you all. Bye.